What does it take to do the most important job in the world? More than 100 years ago, a young farmer in rural Germany spent much of his time fixing a notoriously unreliable hay binder in order to get the job done. So, he went on to invent a better tool. After starting his company in 1913, August CLAAS began a long line of innovations designed to simplify the lives of countless farmers around the world. Today, the company proudly supports over 11,000 employees, 5,000 patents, and 500 different products sold in more than 160 countries through 35 production and sales facilities and hundreds of importers and dealerships. Our customers, independent, business-minded ag professionals, pay attention to the little things because they know they make a big difference. Bright minds who demand more from themselves, the land they live on, and their equipment. We're here to build them brighter tools to help them achieve their goals. Tools like our global industry-leading Jaguar forage harvesters, outstanding hay and forage tools, top-performing tractors, and the unequaled Lexion Combine. Equipment designed to save time, increase productivity, improve profitability, all while providing our customers with greater insight to make brighter business decisions. And make the most important job in the world just a little easier.
Thank you for considering to work with CLAAS Omaha for your Senior Capstone Engineering Design Project. I'm Matthew Cook. I'm the Director of Manufacturing for CLAAS Omaha. And behind me is arguably one of the most complex machines in the world. This particular one is made in Omaha, Nebraska. Today, a modern combine harvester utilizes various functionalities to efficiently harvest the grains needed to feed a growing population. In the last 20 to 30 years, the complexity of these machines has increased significantly. From high horsepower engines to the drives to threshing, separation, a multitude of other functionalities that allow a farmer to efficiently harvest. That combined with new technologies, GPS, auto steering, data acquisition systems, these are all combined to make the farmer's job easier. But one thing hasn't changed in the last 20 years. It's the number of bolted joints used to make machinery such as what you see here in front of you. Here you see examples of where our technicians have marked manually the bolted joints when they've reached torque with the specified tool that they've used. And what we would propose is that we develop a system, an add-on to our torque tools, that would systematically, mechanically provide a witness mark upon the tool's completion of its torque cycle. This is an example of one of the air-powered tools that we use on every single bolted joint on this machine. Whether it be a manual click tool, an air-powered tool like this that costs maybe $3,500, has an accuracy of about 5%, to DC-powered tools, every single bolted joint on this machine is torqued to specification. What we would propose is an add-on solution to this tool that takes the signal from the clutch, the vibration occurring as the torque tool reaches the set torque limit, or the air exhaust coming out the back end that occurs at the same moment. Take that signal, process it, and provide a means to provide this witness mark to the bolt head. The proposal that we're providing you today would not only benefit the production of this Lexion combine in Omaha, Nebraska, but it would as well be useful for the other various products and facilities CLAAS has worldwide. It's very apparent that the quality control that we're pursuing with this idea isn't applicable only to CLAAS, but instead to our competitors, as well as a wider range of industries making very complex machineries with a very complicated arrangement of bolted joints. We hope you choose to partner with CLAAS to address this very important topic. And now I turn it over to Chase Goddard, our manufacturing engineer for CLAAS Omaha, to discuss more of the purpose and the context behind this proposal.
Thanks, Matt. We'll head out to the production floor and look at these pneumatic tools in operation.
Go.
All right, here we are on the shop floor. Assembly technician Dennis, he's going to demonstrate this fastening joint here. Go ahead, Dennis. So he'll go through, tighten all these bolts down within an assembly, and then once he's done, he visually marks them. Here, this has already been done with blue paint. Those have reached the desired torque values. More of the other. Over yon. And then he'll go through and mark with a paint pen to show that his torque has been achieved, so it can visually be inspected by quality. Alright, so here's another example of maybe a tight fitting area where an air powered tool would be needed. Alright, we see again, tight fitting area needs to have minimal interference with the machine, and we mark with the paint pen to visually see again afterwards. Alright, here we have an example of a little bit larger air powered gun, 207 Newton meters, so here we go. All right, now that we've seen some examples on the production line, we'll just recap a little bit of what we saw. So all the areas of the machine have thousands of joints fastened per day in the facility. We have tight fitting areas, multiple different tool sizes, multiple different torques. Both the head and the nut side end up getting torqued. And of course, we have a desired solution that Matt had explained to us. We're looking for a reliable, systematic method to create a witness mark to place on the top of the bolted joint once the torque tool has been completed through its torque cycle. With this project, it's a multidisciplinary project, and it gives a real industry scenario where you work on a system with several parts and other types of engineers. Some of the technologies we expect that could be used would be sensors, which are endless possibilities there, pneumatic controls, paint and ink marking, controller programming, power supply, component design, and machining. So some considerations to take when tackling this project. Needs to be low profile, lightweight, and work in tight spaces. We want some quick drying and permanent marking ink. The paint pens that we have, potentially if there's a system to use with those. Ideally, we'd want 250 bolts to be fastened per refill, and then we want easy and minimal refill time for changing out new paint or whatever ink we use. We also want reliability regarding the reading and the signal that creates the marking. You have to consider a wide range of tool types, sizes, and shapes, and multiple socket head sizes for either the head or the nut. And of course, it needs to be durable in a factory setting and ability to industrialize this on a large scale. Some technology already exists for manual handheld torque tools. Maybe an add-on solution could be added to these pneumatic air power tools that we see here on the right side. With the durability and industrialization of the project, CLAAS sees this as being a 2-year project where the first year we develop a design proposal and a functional mock-up, with the second year providing industrialization and refining what was developed in the first year and making multiple units for use in the plant. We encourage you guys to be able to come visit CLAAS throughout the project, or if you would like to test anything. It's not necessary, but we'd love to have you and show you our facility. CLAAS is able to come to Lincoln at key points in the project, and we can provide tools, resources, and funding for the project as well. We look forward to working with you and developing a solution. Thank you.